Now let's try another example for the distinct roots, not for the distinct, for the double roots. Example, y double prime plus y prime plus 0.25y equal to 0. So y0 is equal to 3, y prime 0 is equal to minus 3.5. So this is an initial value problem. So we also need to find the values of the constants c1 and c2. The characteristic equation will be m square plus m plus 0.25 is equal to 0. Now this is an equation m square. The value of m we can find from the quadratic formula. So it will be minus 1 plus minus 1 square minus 4a into c 0.25. Okay, m square, yeah, is correct, is it? Yeah. So in this case, the value I find is minus 1 plus minus. Inside of this is 0, so over 2, so the value will be 0.5, minus 0.5. So m1 and m1 is equal to minus 0.5, which is same as m2. So since it is a double root, so the general solution will be c1 plus c2x into e power minus 0.5x. Okay, so now I can input the initial conditions. Y0 is equal to 3, so is equal to 3 c1 plus c2 into 0, and then this term will be 1. So c1 will be equal to 3, and for this second we need to find the y prime. So y prime in this case will be, we can apply the product rule c1 0 plus c2 e power minus 0.5 x and plus c1 plus c2 x into minus 0.5 e power minus 0.5 x. Okay, so now y prime 0 was minus 3.5, so let's simplify y prime a little bit from here. It is c2 e power minus 0.5x, and from here it will be minus 0.5 c1 plus c2 x e power minus 0.5x. So y prime is 0 is minus 3.5. Minus 3.5 is equal to, now it's asking the value c2, and then this will be 1, and then it will be minus 0.5 into c1 is 3, and plus this term will be 0. Okay, and then this term will be 1. Okay, so from here I think we can find the value of c2 directly. Minus 3.5 c2, and this will be 1.5. 0.5 times 3 is 1.5. So c2 will be equal to minus 3.5 minus 1.5, so c2 will be equal to minus 5. Okay. So the solution will be y is equal to c1 3 minus 5x into e power minus 0.5x. Well, a correction will be that because it was minus 0.5, so it will be minus here, and then it will be minus 3.5 plus 1.5, it will be minus 2. So here the answer will change. C2 will be minus 2, so answer will be here minus 2x. So this example involves another case, complex conjugate roots. So the differential equation is y double prime plus 0.4 y prime plus 9.04 y is equal to 0. So the characteristic equation is m square plus m plus 0.4m plus 9.04 equal to 0. So by the quadratic formula we can find minus 0.4 plus minus 0.4 square minus 4 into 1 into c. So it will be equal to over 2 into 1, 2a. So if you will simplify it, then the answer will be, so this value will be minus 0.4 and this value will be minus 36. Okay, if you will, so divided by 2, so it will be, if I divide it by 2, it will be 0.2 plus minus 36, square root is 6, and then for minus 1 it is I divided by 2, so it will be 4. So finally we will get two roots, 0.2 plus and then minus 3i. Okay, so this is the complex root. So for the complex roots, if we get the complex roots, we can get a solution in this form. It is equal to e power minus a x into a cos omega x and plus b sine omega x. Okay, so in this case, what is a? A is this. This is a. And what is omega? Omega is this. So the solution is e power minus 0.2 x into a cos 3x plus b sine 3x. So in fact we can verify this solution by the substitution. The derivation of this rule is not that difficult. It can be easily proved by applying the Euler's formula, which says that e power I theta is equal to cosine theta plus iota sine theta. Okay, so this identity will be used, and then the coefficients can be compared on the left and right hand side. So then we can easily get this formula. In this course we are not going too much into the derivations. We will be focusing more on the application. So the application of this type of case results into this type of answer. So it is then we need to remember the case and then the form of the answer. It was a initial value problem, so that's we can find the values of these arbitrary constants a and b by applying the initial value problem. The initial values were y 0 0 and y prime 0 is 3. Okay, so if we say y0 is 0, so that means 0, and then this term will be 1. And how about this term cosine? This term will be 1 cosine, so it will be a, and then the next term will be 0, sine of 0 0. So a will be 0. And then if I take the y prime, so y prime will be, we need to find y prime by the product rule, e power minus 0.2 x. It will be then minus 3a sine 3x plus 3b cosine 3x, and then the next term will be minus 0.2 from here, e power minus 0.2 x into a cosine 3x plus b sine 3x. Okay, we can simplify it, or maybe it's not needed, just apply the values. So y prime was 3 for x is equal to 0. So for x is equal to 0, this term is 1, and this term is 0. This term will be 3b. Okay, and then this will be minus 0.2. This term will be 1. This term will be 0 because a was 0, and the next term will be also 0, so 0 plus 0. So that means that whole next term will be, second term will be 0. So first term will give b is equal to 1. So in the end, then we get a solution. Y is equal to, because a was 0, y is equal to a power minus 0.2 x times b times sine 3x. So this is the solution. So another example, it's a very simple one, y double prime plus omega square y is equal to 0. So if characteristic equation will be m square plus omega square is equal to 0, m will be equal to minus omega square. So sorry, m square is equal to minus omega square, so m will be equal to omega I. Okay, so in this case, for the solution a is equal to 0, that means the general solution was this: a is equal to e power minus ax times a cosine of omega x plus b sine of omega x. So a is 0, so this term will be 1. Okay, omega is omega, and we say that omega is not equal to 0. So the solution is simply a cosine of omega x plus b sine of omega x.